concurrency. Let's talk about concurrency and multithreading. First, what is concurrency and multithreading? Concurrency is the ability to run several programs over several parts of a program asynchronously or in parallel, in which you have multiple threads of execution inside the same application. What is a thread? A thread is a basic execution unit that has its own program counter set of the register stack, but it shares the data, code, and file of the process to which it belongs. Multithreading means that you have multiple threads of execution inside the same application. In terms of the relationship between a thread and the CPU, a single CPU will share its execution time among multiple threads, and the CPU switches among these threads so frequently, making an impression on the user that all threads are running simultaneously. It is also possible to have the thread of an application be executed by different CPUs. Let's talk about multitasking and multithreading. Multitasking is when a single CPU performs several tasks, for example, program process, over a certain period of time. To perform multitasking, the CPU switches among these tasks very frequently so that the user can interact with each program simultaneously. The resources of the process, like memory and the CPU time, are allocated to it via the operating system. Process runs independently and isolated of other processes. It cannot directly access shared data in other processes. Multithreading allows multiple threads of a single task, program, process to be processed by CPU at the same time. A thread has its own call stack, and a thread can access shared data of other threads in the same process. Every thread has its own memory cache. If a thread reads shared data, it stores this data in its own memory cache. If a thread can read the shared data. A Java application runs by default in one process. Process can have multiple threads simultaneously. So within a Java application, you work with several threads to achieve parallel processing or asynchronous behavior. Why do we use concurrency? It helps us better utilize multiple CPUs or CPU cores and distribute CPU resources more fairly. Because a modern computer has several CPUs over several cores within one CPU, concurrency makes it possible to utilize them more reasonably, which is vital for successful high-volume application. It can also help users get better experience with regards to responsiveness. With concurrency, since a time-consuming task can be performed asynchronously or in parallel, it improves the throughput and the interactivity of the program. And if one thread of the application is not responding, the other would respond. But it can also lead to some issues like access and visibility problems, and they would probably lead to liveness failure, which means the program doesn't react anymore due to problems in the concurrent access of data. For example, a deadlock, which means all processes are waiting for an event which another process in the same site has to cause. It could also lead to safety failure, in which the program creates incorrect data. Moving on, let's talk about some concurrency code in Java. Java provides thread class, and we can create new threads via it. We can also import a Java util concurrent package. First, let's talk about how to create and start threads. So we use the thread class constructor to create a new thread and call the start function. But since we didn't specify any code for it to execute, so it will stop right after it started. We want to get the information about which code a thread is running. Then we can use 3 methods. First, we can create a subclass of thread and override the run function. So we created this myThread subclass, which extends thread, and we override the run function, which will print out myThread running. Then we can create an instance of the subclass in the main and call the start function. Then it will print out myThread running. Second, we can also create an anonymous subclass of thread inside main, and it will print out a thread running after calling the start function. Third, we can implement the runnable interface. The interface is like this, and there are 3 ways to implement the interface. First, we can create a class. In this example, we created a class called myRunnable, which implements the runnable interface, and it will print out myRunnable running. We can also create an anonymous class in the main to implement the interface. Third, we can also use lambda to print out lambda runnable running. Okay, let's talk about thread names. In this example, new thread is the thread name, which is passed as a parameter to the thread constructor. We can obtain the name with using getName function. If we use a runnable implementation, we can pass a name to the thread when we use it. Moving on, let's talk about concurrent thread function. It will return a reference to the thread instance which is executing this function. And after obtaining the object, we can call methods on it. Like in this example, we call the getName method. Let's take a look at this example, which contains some points we talked earlier. So we created a myThread subclass, which extends thread and overrides the run function. And in main, we created the myThread instance and call the start function. Then it print out myThread running in console. We also want to print out the name of current thread, which is main. Afterwards, we use a for loop to create 10 threads from thread 0 to thread 9, and create an anonymous class to print out and use the getName function and the start function to print out which thread is running. Okay, let's talk about how to pause a thread. We can use the static method threadSleep. It takes a number of milliseconds as parameter, so the function will attempt to sleep that number of milliseconds before resuming execution. In this example, the code will sleep. The function will sleep for like about 10 seconds. And in terms of how to stop a thread, we need to implement runnable, which contains a function called doStop. Let's take a look at the Eclipse to see this example. So we created a class called myRunnable to implement a runnable interface. And in main, we created an instance of myRunnable class and pass it to thread constructor, and then call the start function of thread. At the end, we stop the myRunnable interface, and before it stops, it pauses for 10 seconds, and between these 10 seconds, we can see in this myRunnable run function, it will print out running for every 2 seconds. So when we run the code, it will print out the running for every 2 seconds, and it will print out 5 in total. If we change 2 to 5, then it will print out running for every 5 seconds and print out 2 running in total. And if we change it to 3, it will print running for every 3 seconds and 4 in total. Okay, let's talk about logs and synchronization. Java provides logs to protect certain parts of the code to be executed by several threads at the same time. We can use the synchronized keyword to realize it. It ensures that only a single thread can execute a block of code at the same time, and it can also shows each thread entering a synchronized block of code to see the effects of all previous modification that was guarded by the block. Synchronization is important for mutually exclusive access to blocks and for reliable communication between threads. This keyword can be used to mark different types of blocks. First, it can be used in instance methods. In this example, it is used for both add and subtract methods. In addition, it can also be used for static methods. And compared with using synchronized for the whole method, it can also be used for just a part of the method. And the rule also applies to static method. So you can see from this example, compared with the first one, which used synchronized keyword for the whole static method, in the second function, we just use the keyword for part of the static method. In addition, synchronized blocks can also be used in lambda expression, like here. And let's take a look at a synchronized example. So we have two classes, which is counter and counter thread. And in this code, we created a counter instance and pass it to thread A and thread B. But since the add method in counter is synchronized, only one of the threads A and B can call the add method at a time. The other thread will have to wait until the first thread leaves the add method. But if we create two counter instances and pass them separately to thread A and thread B, there will be no problem of calling the add methods simultaneously.